Welcome! Today we're going to learn about critical numbers. Okay, so what's a critical number? Well, first of all, it's an x value, so we have to start there. And we're going to call our x value c to represent our critical number. Okay, so start with item 1. First of all, our function must be defined where x is c. 2, if our first derivative at c is 0 or the first derivative does not exist, then c is considered our critical number. And in item 3, if the function has a relative minimum or a relative maximum at c, c is our critical number. So let's look at two graphical examples here. If you look at the graph on the left, you will see that we have the graph is in the shape of a hill, and that means that we have a relative maximum at that location. You can see this in item 2. Also, I can draw a horizontal tangent line to my curve at that location. And anytime you can do that, you have the first derivative there is 0. Okay? And so that qualifies as a situation where I have a critical number. So c is 0, or x is 0, at that location where we have our maximum. And if it happened to have been a minimum, it would be the same situation. We would have still had a critical number. Now let's move on to the graph on the right. In this graph, the shape is such that, yes, we do have a minimum because it's shaped like a valley, so we have a relative minimum. However, the difference here is we have a sharp turn in our graph at x equals 0. Anytime you have a sharp turn in your graph, that means at that location your derivative, your first derivative, does not exist. Another case where your first derivative would not exist would be, say, if you could draw a vertical tangent line to your graph at a particular location, the first derivative would not exist at that location as well. Okay? But in this graph, the main thing is at 5, we have a sharp turn. So at that location, c is 0 or x is 0. That is where we would have a critical number. Okay, so that's graphically our situation, but what about analytically? So in 1, we're given a function. We're asked to find critical numbers. What do we do? Well, in step 2, the first thing we're going to do is take our first derivative, set it equal to 0, and solve. And in 4, you see we get x equals 1, and that would be our critical number. In this example, we're also given a function. We happen to have a radical, so we want to change it to an exponential form just to make our derivative easier using power rule. And we do that in step 2. We convert it then back to radical form. And unfortunately, if we set this equal to 0, we're not going to be able to solve. So we also look at the first derivative being undefined. Well, that is going to occur when x equals 0. So that qualifies as a situation where we have a critical number. So x equals 0 would be our critical number. The only thing you have to be very careful of here is you want to make sure that does not make the original function undefined. So if you go back to 1 and you plug in x equals 0, make sure that works. In this case it does, so x equals 0 qualifies as a critical number. And that is our lesson on critical numbers. Now go practice, practice, and practice some more.